Hello everyone, we are back with another Leetcode problem. Today we are going to discuss the first problem, to sum. This is the first problem of Leetcode and this is a problem within the blind 75 list. This is going to be an easy problem, but I like this problem because this one is an example problem of how you can approach any problem. So how can you think in a naive way and then make it more and more efficient? Okay, so this is one of such problems, and using the concept or thinking process of this problem, we can apply to many other problems. So the problem description says that given an array of integers, the name of the integer is nums, and an integer target. So two things were given: an array of integers, nums, and one integer target. We have to return the indices of two numbers such that they add up to target. So the return value is going to be the two of the indices of the array. We may assume that each input would only have exactly one solution. So the answer is going to be just two indices, not multiple pairs, right? Not multiple pairs, just two indices. And you may not use the same element twice. That means each of the elements in the input array are also, yeah, you cannot use one element twice. Okay, so there is just unique one. You can return the answer in any order. Yeah, that's also fine. That means say indices 3 and 4, that is fine. Or we can say like 4, 3. That is also fine. Okay, so let's look at one example. This is the array of integers given, and this is the target value. Okay, so we have to find two values that sum up to this. As we see here, 2 and 7, they sum up to 9, right? So their indices are 0 and 1. So that's why you see the result is going to be 0 and 1. The next example, 3, 2, 4, this is the array given, and the 6 is the target. Now you see that 2 and 4, they actually add up to 6. And their indices are 1 and 2, so the output is 1 and 2. Third one, 3 and 3 is the input. Target is 6. And as you see, 3 and 3 add up to 6. So the output is index 0 and index 1. Okay, so it's given that there would be just one pair where there'll be just one pair where the summation is going to be equal to the target. Okay, so how do we find those numbers? So here is one thing. Yeah, so here's one thing. Let's do this. Let's say we have to find a pair, right? Okay, so why don't we just, for the first example, 2, 7, 11, 15, and we have to find our target is 9, right? Target is 9. So what we can do is we can actually start pairing up every value. So 2 will pair up with, say, 15, 2 will pair up with 11, 2 will pair up with 7, right? So let's say 2 and 15 is 17. So this is not right. 2 and 11 is 13. So this is not our target. But 2 and 7 is 9, which is our target. Okay, so then we found our pair. So this way we can actually, in this solution, what we can do is we can try every pair, right? Every pair, and see if that pair actually sum up to the target, right? So that's an easy solution. I would say the naive solution. And so how many elements are here? N, right? If I pair every item with every other item, how many pairs would be there? So the naive solution is order of, because there might be order of any square pairs, right? Because if I pair up each element against other element, so each element will be paired with n elements, and in total there are n elements, so n into n pairs. So the naive solution is order of n square. We create n square pairs and then check if their summation is equal to the target, right? Okay, so how do I improve on this? Let's revisit what we were doing in the naive solution. When we were actually checking 2, right, we are pairing up 2 with everything, right? So instead of pairing up with everything, can we just reduce the cost by asking what we actually require? So we are targeting 2, right? So if we are targeting 2, what do we need? We need 2's complement, right? Target is 9 minus 2, 7, right? So if we ask the question, does this array, does it have 7? Okay, so what is the fastest way to answer that question? One fast way to answer that question is having a hash map. So if we somehow had a hash map where we could put all the values, right? Say 2, 7, uh, say 272 is, and their index, say this is a value and this is the index. The index is says 0, 1, something like that, right? To then we could just go to the hash map and say, hey, do you have 7? And the answer was yes, I have 7. Yes, and the index is 1, right? So then I could just get my answer. Now inserting all these values into the hash map, their n values is order of n, because we know that the hash map operations are order of 1. So we have to insert n of them. So this is like putting in the hash map is order of n, and lookup for each time the lookup becomes order of 1 for each time, but we will first check 2 and then 7's complement and 11's complement and 15's complement. So every time, so at most in the worst case, we may have to do n lookups. So the lookup is also going to be order of n. So overall, this algorithm is going to be, so the time complexity is going to be order of n. So the time complexity is going to be order of n, and the space complexity is going to be order of n as well, because that is the trade-off. Like in the naive solution, we didn't use any space, but now we have to use order of n space, because that in the worst case, the hash map will have n entries. Okay, so let's think, let's try to see how this exact problem is going to look like. So we will have a hash map at the beginning, and obviously the hash map will be empty. So what we can do is we can start reading from the left. So we start reading from the left. 2, we're reading 2, and then we're calculating what do we need, 7. Does it have 7? We'll go to the hash map. You see, the hash map currently doesn't have anything. So the answer is going to be no, right? It doesn't have anything yet. So instead of green, let's put another color so that it looks more realistic. Okay, because the answer is no, with the hash map doesn't have anything right now. Okay, so that's fine. What we'll do is we'll immediately put 2 and its index 0, right? Next, we are going to read 7. Okay, so we are going to read 7, and then we are going to see what we want. So we see 9 minus 7 is 2. So we are going to ask, does the array has 2? Now you see here, and we go there, and now the answer becomes yes. All right, and already we know that we are at index 1. And from the hash map, the index that we get is 0. So we can say, okay, we have it yes, and the index is 1, 0. That is the result. So that's the optimized solution, and we'll go to the code. Okay, so let's code this, and I will try to use the hash map. The hash map's values are going to be the values of inside the array, and the other pair is going to be the index of that value. Okay, and then we'll start from reading from index 0. Okay, and then we'll check if, and okay, so we will also we'll need a result, array for result. Okay, then we are traversing the array and checking if target, okay, if the hash map, so I have to give it a name, right? Yeah, if map contains key, it has to find its pair, right? So the current value is nums I, this is the current value, and the pair value is going to be target minus nums I. If map contains this, then I would say result 0 equals to I. And result 1, the other pair value is going to be map.get this value. So this will bring out the index of the paired value, right? And then I return result. Otherwise, what I do is I just add to the hash map.put the value nums_i, this is the current value, and the index. Okay, return result. Well, it's in the problem description says that we have a pair already, so this will hit here. So this is just yep. So this is just for this function, but if the constraints are correct, it's never going to come here. Anyways, let's run this. Accepted and submitted. Okay, so this is the order of n algorithm with space complexity of order of n.